Okay, so for chapter 3, we're looking at volume, and today's section is 3.1, cube and cube roots. We've done square and square roots previously, so this will be learning how to cube a number and what a cube root is. So in part A, in class, I would have asked you to use linking cubes, like those centimeter cubes, to make to build 3 cubes. So this is an example of the centimeter cube because it's 1 centimeter by 1 centimeter by 1 centimeter. To build 3 cubes with side lengths of 2, 3, and 4, and then to draw the cubes below. So here's an example of a cube with a side length of 2. So it's 2 by 2 by 2. So you can draw that here. And then here I would have asked you to build a cube with a side length of 3. So I've done that for you here. So we have 3 by 3 by 3. And then with 4. So I've got one here with 4. So 4 by 4 by 4. So there's 4 by 4. By 4. And then fill in the following chart. So when we had a side length of 2, so in this example here, we have a side length of 2. How many blocks do you have in total? So what I would have asked you to count up how many you have here. So you have 1, 2, 3, 4, and then 5, 6, 7, 8. So I've got 8 blocks in total. When you had a side length of 3, so that's this one here, I would have asked you to count up the total number of blocks. So we have 9 here, 9 in this section here, and 9 in the section on the bottom. So if you were to count them up, you would have 9 plus 9 plus 9. So you would have had 27 in total. And then this one here, when you had a side length of 4, and I asked you to count up how many cubes there were in total, you'll notice there is 4 plus 4 plus 4 plus 4, which is 64. Which is 16. And you have 4 stacks of them. So 16 plus 16 plus 16 plus 16. So you have in total 64 cubes. Okay, so how does the total number of cubes relate to the side length? So what you do, if you look here to look for a pattern, how do you go from 2 to 8? How do you go from 3 to 27? How do you go from 4 to 64? And we're talking about cubes. So we are taking this number here, the side length, and multiplying it by itself 3 times. So 2 times 2 times 2 gives us 8. 3 times 3 times 3 gives us 27. And 4 times 4 times 4 gives us 64. So this is going to lead us into volume. So how does the total number of cubes relate to the side length? What you do is you multiply the side length, so we'll take the example of 2, for example, with itself, twice, and that gives you the number of blocks. So for example, 2 times 2 times 2 gives you 8. So let's go into some vocabulary. A perfect cube is the product of the same 3 numbers. So some examples of perfect cubes, because we've talked about perfect squares in the past. So like 16 is a perfect square because it's 4 times 4. 25 is a perfect square because it's 5 times 5. Now we're looking at examples of numbers that are perfect cubes. So we can go 1 times 1 times 1, which is 1. And we can go 2 cubed, so 2 times 2 times 2, which is 8. So 8 is a perfect cube. And we can see what happens. 3 times 3 times 3, which is 27. So 27 is a perfect cube. And 4 cubed. So 4 times 4 times 4. We're multiplying it by itself 3 times to give us 64. So these are all numbers, and we could keep going, right? We did that with the perfect squares. We would do 4 squared, 5 squared, 6 squared, 7 squared, etc. We could keep going. And we found that these numbers here were all perfect cubes. Okay, so on the back side, a cube root of a number is just the opposite. It's the number that's being multiplied with itself, or the number being cubed to give you the perfect with itself, twice, not just once. So for example, 8, what's the cube root of 8? So how do we get 8? It would be 2 times 2 times 2, which is 2 to the power of 3. So we would say that the cube root of 8 is 2. Okay, so relating it back to here, if we have 8 here, the cube root of 8 is 2. If we have 27 here, the cube root of 27 is 3. So it's the side length. So in example 1, sketch or build a model to determine the value of 4 cubed. So I've got one made for you already. So this is 4 cubed. So 4 times 4 times 4. Length times width times height. 4 times 4 times 4. And you can draw it. You can sketch the model. Okay, and we want to determine the value of 4 cubed. So what is 4 times 4 times 4? And that equals 64. Example 2, sketch or build a model of a cube with a volume of 125 centimeters cubed. What is the cube root of 125 centimeters? So I don't have one made, but basically instead of going like 2 by 2 by 2, I would have done what I have 125 blocks, so how would I arrange them, right? That's the question. So what is the cube root of 125? So what times what times what gives me 125? And the answer is 5 centimeters. So 5 times 5 times 5 gives me 125. In example 3, what is the cube root of 512? So we can do this a couple of ways. We can draw a factor tree. So we break down 512 into 4 times 128, 2 times 2, 16 and 8. So I just keep breaking them down until I get prime numbers only. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 2s. Okay, so 512 is 9 2s multiplied together. Okay, and if I put them in groups of 3, because I'm looking for the cube root, how many groups do I have? So I have 3 groups. So the cube root of 512 is the value of one group. So 2 times 2 times 2, which is 8. So the cube root of 512 is 8. You can also use your calculator to find the cube root. So your cube root button, so mine is this one right here on top. You'll have to play around with it. So in my calculator, I had to press 3, shift, and that key, and type in 512. So that's basically so this 3 really belongs where the x is. So what times what times what gives me 512? And the answer is 8. So you can use your calculator, or you can use a factor tree, come up with how many prime factors you have and how many groups. You put them in 3 groups and find the value of one group. Okay, next question here, example 4. What is the cube of 9? So now we're not looking for a cube root, we're looking for a cube of 9. Just like you could find the square of 9, or you could find the square root of 9. So the cube of 9 means 9 cubed, or 9 times 9 times 9. And same thing in my calculator here, and you can look for it in your calculator. I use this key right here. So 9 to the power of 3. So that means 9 times 9 times 9 gives me a value of 729. Okay, so that's the end of this lesson here.